Okay, this is the final video. What we have is we have OSPF running on these four routers, but we need to completely control who's going to be the DR and the BDR. Let's say we want R0 to be the DR because it's the most robust router, and then the second most robust router is R3, so we want R3 to be the BDR. Well, let's set router priority numbers and see and use that as another way of influencing the election process. So I'll go to R0, and I'm going to have to put in the password Cisco, and then the enable command and the password class, and then I'm going to do a conf t to get to global config mode, interface fa0/0. Okay, and then now I'm going to do a question mark, right, and I'm going to do I think it is an IP question mark, and that's going to be OSPF question mark priority, router priority. Okay, so IP OSPF question mark, so we're going to say priority, whoops, and then another question mark, all right, and then it's a number from 0 to 255. Now if we want to make the router have no chance of being the DR, we'd set it to 0. But we want it to be the DR, so I'm going to set it higher. The default is 1, right? They all currently have a priority number of 1. So I'll set it to 100. Okay, so that's done, right? And then I'll do a Control C, and I'll save my configuration. Copy, run, start. Okay, so I just saved my configuration file. And then I'm going to do on R3, I'll type enable conf t interface fa0/0 and IP OSPF priority, and I'll set this one to 50. IP OSPF priority to 50. Okay? Now, the other thing that I'm going to do is I'm going to shut down this interface. I'm going to shut down that interface, all right? And wait, copy, run, start, and oops, well, I have to do that command in. Okay, there we go. Let's copy my configuration, and I'm going to go back into the interface. So now I'm ready to start it up again. So I shut it down, and what I'm going to do now is, see, this interface is shut down. I'm going to shut down, I'm going to cheat on these other ones and just use a little tool here to go quicker and shut down all the interfaces right here, right? Or we reload the process, or basically I want to influence the election process is what I want to do. So on R1 we'll shut down an interface, right? And then on R0 we'll shut down an interface, right? And since this router has a very high interface number, so we shut down some interfaces, and then we can just turn them back on, and I'm going to see if that will work in helping decide who's going to be the DR. So I'll turn on this interface for R0 first, and then I'll turn on this interface for R3 second, hoping that this guy will be the DR and this one will be the BDR based on the order in which the interfaces are turned on. And I'm not sure if that's going to work. I'm just testing it out. But we know that an election is forced when interfaces are turned on and off, and so that would be one way to do it, is to just start the routers in the order that you want to have them start, and then see if that works in setting up who's the DR and the BDR. We know that the router priority numbers are correct here. This router has a router priority number of 100, this one has 50, and so that should help influence it. So now, do a C here, and we'll do a show IP OSPF neighbor, and we can see that the adjacencies are still happening. And you can see that according to R2, which is this router here, the DR is the router with the priority 100, right? So that worked. And the BDR is the router with the priority number of 50, so that worked. And so we have the correct routers having DR and BDR status on the network. And if we want to see packets being exchanged on the network, we can go into simulation mode and try to do that. So I've edited the filters to show OSPF only, and then I'm going to run the simulation, auto capture play, to see OSPF packets happening on the network here. Okay. And I believe that these packets that we're seeing happening here going across the network are hello packets. Let's take a look here. Inbound PDU details, and we'll see what it is. OSPF link state acknowledgement. Okay, so there we have an LSA packet. Let's take a look at another one. And this one is also a link state update. Okay, type 4. Link state advertisement. So interesting. I'd like to spend some more time with that. You can see here I saw an outbound PDU detail off of this one right here. Outbound, you can see it's an OSPF hello packet that we can take a look at and see the hello interval for OSPF is 10. The dead interval is 40. So all these routers have to have the same hello interval set if they want to communicate successfully. And they also have to have the same dead interval. The hello interval is set to 10, dead interval is set to 40. That's by default, right? And so it's fun to look at these packets and analyze them and see OSPF kind of happening in real time. The other thing that I would like to see happen in simulation mode, so I've reset the simulation. You set the edit filters to just OSPF, right? And the other thing I'd like to see happen is watching if I take, let's say, R2 right here, and then turn off the Ethernet interface on 01. So let's say this LAN goes down. Well, according to OSPF rules, then R2 is going to send link state updates, and it's going to send it to the DR, which would go to R0, and then the DR would disseminate those link state updates to, or link state advertisements, right, to R1 and R3. And so I'd like to see that process possibly in action. And what you would do is you just set it up, right, and then hit auto capture play, right, and then turn the interface off, and you could see it happen live. So I could say, let's say auto capture play, right, and those are some hello packets going out, and then all of a sudden I just turn off this interface, right, and now there we should be seeing some packets happening now. Okay, there goes this packet, this blue one here. Alright, and the blue one goes here. Notice how there was X's over here, and then this should go to all three. Now let's take a look at that. So that was inbound PDU detail. That should be a link state update, and sure enough, it is. Link state update, right?